Good day, students. In this clip, we're going to be going over an example on how to solve absolute value inequalities that involves two absolute value quantities. All right. So let's go ahead and take a look at the first question. All right. So for question number one, we're going to solve the absolute value inequality x minus 3 is less than 2 times the absolute value of x plus 2. Okay. So first thing, there are different ways you can solve this inequality. There are actually three ways. You can do it by graphing, by creating two different absolute value inequalities, or by converting this into a quadratic inequality. Okay, I'm going to do the last method, which is converting this absolute value inequality into a quadratic inequality. All right, so to do that, what I'm going to do first is basically square both sides of the equation. So I'll square the left side, and I'll square the right side. And then when I do that, I get x minus 3 quantity square is less than, you have to square these two terms in the parentheses. 2 squared is 4 times times x plus 2 quantity square. Okay, now what I'm going to do next is set it equal to 0. You know how to place quadratic equations in standard form before you solve them. So that's the whole idea here, making it equal to 0. So I'll subtract 4 times x plus 2 square from both sides. So I'm going to end up with x minus 3 quantity square minus 4 times x plus 2 quantity square, and that will be less than 0. Okay? All right, now let's expand this completely to have an expanded quadratic inequality. So we have x minus 3 times x minus 3 minus 4 times x plus 2 times x plus 2 is less than 0. Okay, so when you expand this completely, you have x squared minus 6x plus 9 minus, when you expand this and distribute the 4, you have 4x squared minus 16x minus 16. Remember, this minus changes the signs of the in between the terms here, okay, and that less than 0. Okay, so let's combine this. Combine like terms, combine the x squares. We have negative 3x squared, negative 3x squared, and then negative 6, negative 16x will give us negative 22x. And then combine 9 and negative 16, that gives us negative 7 as less than 0. Okay? Alright, this minus here is annoying. How about I multiply the entire equation by negative 1? If I multiply the entire equation by negative 1, that's going to invert the inequality sign. Okay, multiply by negative 1. So I'm going to have 3x squared plus 22x plus 7. Remember, anytime you multiply an inequality by negative, the inequality reverses direction. So since it's less than here, it's going to become greater than 0. Okay? All right, so now what do we have? We have a quadratic inequality, okay? All right, so what I'm going to do next is I'm going to factor this, find where the sign change happens, and then I'm going to test the intervals between the sign changes to see which intervals are actually true and which ones are false, all right? So let's go ahead and factor this quadratic expression right here. I'm going to use the AC method. Make my little x on the right. So AC is 21 and B is 22. Okay, so two numbers that multiply to give you 21 and add to give you 22. 1 and 21 meets this description. So we're going to have 3x squared plus 1x plus 21x plus 7 is greater than 0. Okay? Alright, so let's factor this by grouping. I'm going to break it down the center. From the first two, I'll factor out an x as the greatest common factor times 3x plus 1. And then from these two, I can factor out 7. That's the greatest common factor. I'll be left with 3x plus 1 greater than 0. Okay? All right, and then we'll factor out the 3x plus 1, so you're common, 3x plus 1. And then you're left with x plus 7 greater than 0. Okay? All right, so now we have this factored quadratic inequality. So we need to find where the zeros are, where this inequality, where this function actually hits the x-axis. So to do that, we're just going to use the zero product property to set these two to 0 and then solve. Okay? All right, so to do that, we're going to go 3x plus 1 equals 0, and x plus 7 equals 0. All right? So if we solve this, subtract 1 divided by 3, we're going to have x equals negative 1/3. And then this one, we subtract 7 from both sides, we have x equals 7. Negative 7, sorry. All right, so these are where the sign changes happen, okay? So now we're going to create intervals, and then we're going to solve. There are two ways of doing this. One way is by making use of the graph. Another way is by testing intervals, okay? So let me show you a shortcut method that requires very little work. Method 1 is using the graph, okay? So I take a look at this quadratic inequality. I notice that a is positive, so the opening of my parabola is going to be upwards, okay? So I can easily use these roots to sketch what the graph looks like. Okay, so I'll sketch it like this. The roots, there are two roots, both negative. The first root is negative 7, and the second root is negative 1/3. Okay, so since it's an upward facing parabola, it's going to look something like this, like that. Okay, now I'm looking at this one right here. Now the question is, when is it greater than 0? Is greater than 0 from here in that interval, and also from here to here. Remember, this is negative 7. So what is this? This is x is less than negative 7, and this one is x is greater than negative 1/3. Guess what? That's your answer. Okay? So knowing what the graph looks like, you can basically answer this off the top of your head, you know. Anyway, so this is the solution right there. X is less than negative 7, or x is greater than negative 1/3. Now this is a shortcut if you know how to, sketch the graphs. Okay. Now what if we don't know how to sketch the graph? Let me show you the other method that you see in those textbooks. This is not a shortcut method. You actually have to work it out. So method 2 is using intervals, which I'm going to show you. Method 2 is using intervals. It's longer, but it's easier to remember. Okay. All right. So what I'll do is I'll generate a number line and graph my two values where the sign changes happen. So one of them is negative 7, and the other is negative 1/3. All right, so this is interval 1, interval 2, and interval 3. Now, we're going to pick candidates that we're going to use to test to see if a certain region satisfies this inequality. Okay, so in interval 1, any value of x that's smaller than negative 7 will suffice. Okay, so how about we use negative 8? So interval 1, the candidate is going to be x equals negative 8. For interval 2, any value between negative 7 and 1/3, pick something that's easy. How about we pick negative 1? All right, and then interval 3, anything that's bigger than 1/3, how about we just use 0? That's very easy. Okay, so we're going to test these three candidates. Whichever one is true, that means that the interval is valid. All right, so what are we testing them on? We're testing them in this inequality. We have x plus 7 times 3x plus 1 is greater than 0. All right, we're going to start doing our tests. All right, so let's do our test here. Okay, so for interval number 1, we decided to use, what did we decide to use again? X equals 8, so negative 8, sorry. So I'm going to put maybe 8 in here and see if we have a true statement or a false statement, okay? Let me just put some lines here so you guys can see what's going on. All right, so let's test that. So we're going to have, if I plug it here, we're going to have, the question is negative 8 plus 7 times 3 times negative 8 plus 1, is it greater than 0? If it is, then interval 1 is good. If it's not, then interval 1 is bad. Simplify this, you get negative 1, and then if you simplify this, you get negative 23, basically negative 24 plus 1. Is that greater than 0? This is 23 is 23 greater than 0? Absolutely. So this interval is good. Interval 1 checks. Okay? All right. Interval 2, we're going to test. For interval 2, we're going to test x equals negative 1. That was the candidate that we selected. Any number in between negative 7 and negative 1/3 will suffice. Okay? All right, so that's the one we decided to use. So let's plug negative 1 into this and see if it works out. So the question is negative 1 plus 7 times 3 times negative 1 plus 1, is it bigger than 0? That's the question. So this becomes 6 is 6 times 3 times negative 1 is negative 3 plus 1 is negative 2. Is negative 6, is 6 times negative 2 greater than 0? Is it? 6 times negative 2 is negative 12. Is negative 12 greater than 0? Absolutely not. Negative 12 is less than 0, so this is a false. That means interval 2 is bad. All right, last interval we're testing is interval 3, and the test number is x equals 0. So let's go ahead and use that. All right, so we're going to be using x equals 0 for interval 3. All right, so what we're going to do is we're going to be plugging it into the original function. So the question is 0 plus 8 times 3 times 0 plus 1 greater than 0? That's the question. Is 8, so I'm going to put a question mark here, is 8 times 3 times 0 is 0 plus 1, 1. Is it greater than 0? Let's see, 8 times 1 is 8. Is 8 greater than 0? Is it? Absolutely. 8 is greater than 0, hence interval 3 is good. Okay? So if we go back to our original intervals, we see that interval 1 is good, and interval 3 is also good. So what does that tell us? It tells us that the solution set, remember, the boundary points are not included in the solution region, so we have an open circle here, going to the left, and then we have another open circle here, going to the right. Let's do that again. Have an open circle here, going to the right. So how do we represent these graphical linear inequalities using using algebraically? Well, to do that, we just write it as x is less than negative 7, or x is greater than negative 1/3. Okay, so that's basically what we got before when we're using our graphical approach. So whichever method you want to use, you can basically use to get the solution to this quadratic inequality we got from altering the original absolute value equation involving two absolute value quantities. All right, so that's basically how you solve absolute value inequalities with two absolute value quantities. So thanks so much for taking the time to watch this presentation. You can feel free to subscribe to my channel by clicking here. More clips can be found on mygoserve.com. And please post a comment to let me know what you think about this presentation. Thanks again for watching and have a wonderful day.